in this lesson, we're going to talk about domain and range. This is a really good color coding lesson, so if you have two colors, I'm using red and blue. So every time I talk about domain, I'm going to use red. And every time I talk about range, I'm going to use blue. Okay? I really recommend color coding as we do this. So a domain is the set of all of the inputs, all right? That's your X values. And the range is the set of all the outputs. That's all your Y values. All right, so eventually you're going to talk about something called a function machine. So knowing domain and range is really important because what we're doing is we're anticipating what kind of answers you can have depending on what kind of input that you put in or what you start with. All right, so in our last lesson, we talk about the idea of continuous versus discrete. So our three examples of showing discrete relationships were with sets of ordered pairs, with tables, and with mapping diagrams. So discrete functions, remember these graph as a bunch of just little dots, like a scatter plot. And so to list off the domain and range of those, we're going to list off the values in them in counting order with no repeats. Okay, so let's try that out. So for ordered pairs, the X value is always the first number, right? Because ordered pairs say X, Y. And then your Y values are always the second number. So when I go to list off my domain, what we do with discrete functions is we use these curly brackets to say, hey, we're listing off these numbers. We're describing what's called a set. All right? Now I have to do it in counting order. That means from least to greatest. So out of my red numbers, the smallest red number is 2. And the next smallest is 3. And the next smallest is 5. Now my Y values, okay, those are the ones I highlighted in blue. Again, I make my little set notation. So I'm saying, hey, I'm looking at this set of numbers. So the smallest one's -5, then a 1, and then a 6. I use my curly brackets. So there's our domain and range. Pretty straightforward on these ones. So on a table, remember we said that the domain on a table, or the domain of anything, is the set of all the X values. So our X values on a table are usually on the left, or if it's a horizontal table, they're usually on the top. Will somebody mix that up to mess with you? Maybe. So just verify, like read the heading of your table so that you know. Alrighty, so again, this is discrete, so we're going to use our curly brackets. Now this table is nice because our X values are already in order. So I have -2, 0, 6, 7, and 9. Notice there's commas between each number. We put the commas so that you know that that isn't -20,679. Okay. Now when I go to do my range, I need to point out there's 2 1s here. So not only am I going to reorder it to show counting order, so I'm starting with the -3, but when I get to the 1s, I only list the 1 once, like that. Alright, so then we also get our mapping diagram. So mapping diagrams, they don't always label which one's X and which one's Y. We just assume that you know left side's X, right side's Y. I don't know why we don't bother telling you guys that, but there it is. Now remember, on a mapping diagram, the arrows are describing ordered pairs. So there's 3 separate ordered pairs here is what's happening. Now mapping diagrams, they don't show repeated x's or repeated y's, okay? They'll only list them once, and they always list them in counting order for you right away. So the mapping diagram is actually really easy to find domain and range. Just recognize, like right here, where there's 2 arrows approaching the 12, that means that really 12 was repeated. You just see it through multiple arrows coming through there. All right, so those are our discrete functions. Okay, I believe you learned that stuff in middle school. I might be wrong. I think that the thing that makes it an Algebra 1 thing, high school thing, is now what are called continuous functions. Remember, continuous functions are the ones that you can draw without picking up your pen. Now, the notation for continuous functions changes because I can't just list off a bunch of ordered pairs, because the idea of continuous is that there's always something in between. And if I try to list those, there's always something in between. So I would be forever listing stuff because there are forever points in between. So we have to write it differently, okay? Now there's 2 types of notation that we use for continuous functions, and we have to learn both because we're going to see both in the future. So interval notation, we're going to use that a lot. That's mostly in calculus, but you see it a lot in Algebra 2 as well. Like, we love interval notation. You're going to see interval notation also when we do what's called average rate of change at the end of this unit. Inequality notation, we use that a lot with what are called piecewise functions, which you're also going to see at the end of this unit. So I have to teach you both because you're going to see them both, later in this unit, but also in future mathematics. So I'm going to start with the interval notation because I find that one's easier for kids to see. And then once you have the interval notation, the inequalities are just so easy. So the first thing I want to remind you is that the x-axis is our domain. Okay? Now, if something goes forever to the left, we use a negative infinity to describe that. And if something goes forever to the right, I use a positive infinity to describe that. Now our y-axis is our range. Okay, so if I go down for forever, we'll call that negative infinity. And if I go up for forever, we'll call that positive infinity. Now the part of domain and range that kids struggle with most is that when you're traveling at an angle like this, you're traveling in 2 directions. This is going up and to the right. This one is going up and to the left. And so kids have a hard time kind of divorcing the directions from each other. So like, this bottom one will make more sense when I'm saying that. But just remember, we're talking about left and right, and we're talking about up and down. Okay. So interval notation. So we're going to start with domain. I'm just going to write the letter D so you know domain. Oh, I could just write domain, I guess. Okay. So interval notation almost looks like an ordered pair. Okay, so I'm going to have 2 values. The first one is the left side. The second one will be the right side. And so I'm describing what's called the end behavior. So I'm looking at the ends here and seeing what's happening. All right, so this graph is going to the left, and then I have this arrow here saying it goes left for forever. So I'm going to say negative infinity. So then now I'm going to look for the right. So this graph is continuing to the right for forever. I'm going to call that positive infinity. So our domain here, this is describing left for forever and right for forever. All right, so then our range is going to go from low to high. When you guys are writing these things, it's always the smaller number has to go first. So that's why I do low to high. So how low does this function go? Down to here, right? So this is at the y value, 0, -2. So it goes down as low as -2. Now this interval notation is kind of goofy. If ever you use a number, we're going to use a square bracket, at least in Algebra 1. So for domain and range, you generally always use a square bracket with numbers and then a normal parenthesis with infinities. I know it looks strange. It's just the way it do be. In Algebra 2, we'll extend like why we use the square bracket more often. Just know right now for us, square bracket for number, parenthesis for infinity. Okay, so this went down low to -2. So now up high, these things are going up for forever. So the way that you say up for forever is positive infinity. So infinities get the parenthesis. So there's our interval notation. So now let's do inequality notation. Now when we were writing inequalities, we never use the infinity symbol because it doesn't make sense. The inequality itself is what gives you the infinity symbol. So if your value has nothing but infinity symbols, we just say this funky letter R, which means all real numbers. That's how you say -infinity to infinity with quicker handwriting. It's the funny letter R, all real numbers. Now, I can write an inequality from this one because there's a number available. So remember, the range is talking about y values. So I'm going to use the letter y, and I'm going to use the number 2. So now I have to think, right? Sorry, -2. So I have to think. So if I'm at -2 and the graph is all above it, I'm trying to decide if I should have y is greater than or y is less than. So above it would be greater than. We're going to say greater than or equal to because it exists here. Eventually, an Algebra 2 problem, you guys will learn when to not use the equal to bar. But right now, we use the equal to bar. And there we have it. So let's try it again. So again, this side will be interval, this side will be inequality, okay? So starting with our domain, I'm just writing the letter D because I'm too lazy to rewrite all that stuff. All right, we're looking at the x-axis. To the left is -infinity, to the right is positive infinity. On the y-axis, up is positive infinity, down is -infinity, okay? So when I look at this orange line, this side is going to the left and up. This side is going to the right and down. So when I go to write my domain, I'm looking from left to right. So this one goes left for forever. So I say -infinity. And I use a normal parenthesis because of the infinity part. And this one is continuing to the right for forever. So I'm going to use positive infinity to describe to the right. Now some kids want to say -infinity because it's going down, but I'm not talking about up and down with the domain. I'm talking about left and right. And right is positive. All right, so for our range, I start with how low does it go? So this is going down, down, down for forever. So I'm using -infinity. And then now I'm looking to go up. And this graph goes up, 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 up for forever to positive infinity. Now that makes the domain and range really easy for our inequality notation because neither of these has any numbers for us to write stuff with. So our domain in this case is all real numbers. And our range in this case is all real numbers. So we don't have to actually write any inequalities on that. And that's okay. Oops. All right. This one's a really cool curve. This is called the sinusoidal curve. I know, I sound so nerdy saying it. I love it. So sinusoidal curves follow this pattern. It's like a wave pattern. You guys probably saw it in your science class. I don't know if they were talking about light waves or sound waves, but waves follow a pattern like this, where it goes up and down and up and down and up and down, and it repeats it into infinity. Now, you don't learn about sinusoidal curves. Well, you learn about sine and cosine in geometry, but the graphs of them you don't learn until Algebra 2. So I'm just labeling my infinities and stuff, just to make it easier for me to talk about it. But it's good to see this kind of stuff here in Algebra 1, so that when you do see it later on, it's not some scary thing. It's less weird because you've seen it a little bit before. So this I'm showing you guys to help be less scary. Now, I'm just kind of a crappy drawer here. This was supposed to go just a little bit lower. I'm trying to get it to touch this line right here, just so you guys know. Okay. So, looking at left and right, that's domain. So this line will keep coming like this, right? For forever and forever to the left. So the way we say forever and ever left is negative infinity. And when I go to the right, we were describing it, right? This thing keeps bouncing forever and ever between the same two numbers. Geez, Miss Caswell. Forever to the right. So that'll be positive infinity. Now the range is where the sinusoidal curves are interesting to me, because they always go to the same lowness and they always go to the same highness. Okay? So this one goes down to -1 and it comes up to 2. So my range is -1 to 2. And because those are both numbers, they get the nice little square brackets. So when I go to do my inequality notation, the domain didn't have any numbers in it, so it gets the funky all real number, right? But the range has 2 numbers. So I can't write my inequality like this, because this only uses 1 number. So that's where we have to use our compound inequalities. Ah, Unit 1 is whispering to us from the past, saying, I hope you studied compound inequalities. But this is actually going to be just an and inequality. So, and inequalities, remember, you put your little gators in them. The gators always gobble to the right, every single time. The smaller number has to go first. The larger number goes second. And then the letter in the middle, if it's a domain, you'll use an X, but this one's a range, so I use a Y. And there we have it, friends. So I find writing out the interval notation makes the inequality notation just easy. Now this part is word problems. Ew, word problems. They work pretty much the same way. We just have to think about kind of cause and effect. Okay, so I want you to think of science class. H here's struggling. So in science class, you learn about an idea called cause and effect, right? Something causes another thing to happen. So your domain is the cause. It's the thing that is causing the other thing to happen. And your range is the thing that happens. So what I do to solve these problems is I first identify the units. 1 unit will be domain, 1 unit will be range. And once I've identified the units, I think about what causes the other thing to happen. And then from there, I can think about the reasonableness. So I have a hose that fills a 10,000 gallon swimming pool. at a rate of 10 gallons per minute. So the two units are gallons and minutes. Okay, so I have time and I have volume. So I need to think about, when you're filling a pool, a swimming pool, right, here's your little hose pouring in water. Does the number of gallons that pass determine what time of the day it is? Or the number of minutes that pass, does that determine how high the pool is going to get? Well, nothing can control time, right? Time's going to pass no matter what is happening. So any time that you have time, like minutes, seconds, hours, that's going to be your domain kind of thing. Because time usually determines everything else. So 10 gallons per minute is describing time. So our domain will involve the 10 gallons per minute. It's talking about time. So I have to think, what is the least amount of time that I can fill a swimming pool? I had a lot of kids say 10 minutes during the lecture. But can't I spend less than 10 minutes? Could I spend 5 minutes? Sure. Could I spend 1 minute? Absolutely. Could I spend half of a minute? Great. Could I spend 1 second filling a swimming pool? Yeah. Half of a second? Could I spend 0 seconds filling the swimming pool? I could. Could I spend -1 second filling a swimming pool? No. So my smallest there was 0. Now the most is where kids are going to struggle because they're like, oh, it's 10. But remember, we're talking about minutes, not gallons per minute. So the way that I figure out how many minutes are passing is I would take the 10,000 and divide it by the 10, because that's how many minutes would pass by. So that's where 1,000 is coming from. And remember, I'm using square brackets because I use numbers, right? I can't fill the pool for an infinite amount of time because eventually it would reach its maximum capacity and it would just overflow, right? All right, now the range is a little easier to think about. So the range is talking about gallons. So what is the least amount of water I can put in this pool? None of it, right? I can't put negative water in the pool. That doesn't make sense. But I could put no water in the pool. And that seems reasonable, right? If no time has passed, no water in the pool. Well, that's pretty straightforward. And the most amount of water in the pool, I can't put infinite amount, right? There's a max capacity. And the maximum capacity in this case is 10,000. Now the inequalities on these are actually pretty easy, okay? Because we're given 2 numbers on it. So if I'm thinking about my inequality, should I use this type of inequality or the compound inequality? The one that uses 2 numbers is compound. So let's try it out. So for our domain, I know I'm going to use from 0 to 1,000. My alligators are gobbling right. And then the letter I'm using, the domain, uses x's. So I'm going to put an x here. And I'm using the same process for my range. So I know I have a 0. I know I have 10,000 on the other side. My alligators always gobble right. And the range talks about y's, so I'm going to put a y there. All right. So on our next one, I have a car traveling 25 miles using 1 gallon of gas. So my 2 units are miles and gallons. So I'm thinking about that cause and effect, right? So what is causing the other thing to happen, right? Like the amount of gas that you have really determines how far you can drive, right? You can't just suddenly drive, I don't know, 200 miles on a single gallon, right? You would run out of gas and then you'd be stalled out. So the thing that determines the other one, the thing that causes the other one, is that 1 gallon. So the gallons in this case is our domain, and the distance that we travel is going to end up being our range, because the gallons restricts how much you can travel. So if I'm thinking about domain, thinking about gallons of gas, the least amount of gas I could put in that car is 0, right? I can't put negative gallons of gas in the car. And the most number of gallons I could have here is 1. Now if I'm thinking about mileage, if I go put 0 gallons of gas in the car, I'm going to go 0 miles, right? And if I put a full 1 gallon in the car, I go 25 miles. So again, with these ones, right, our domain, if I'm writing my inequality, starts at 0, goes to 1, and domains use x's, so I put an x there. My range starts at 0, and it goes to 25, and ranges use y, so I put a y there. So that interval notation really makes the inequalities so much easier to write about. So much easier. Just don't forget, the gator always gobbles to the right. Don't be flipping your gators in weird directions. Alright, so this last one. A roller coaster takes 2 minutes to pull the cart to the top of its ramp, which is 75 feet in the air. So my 2 units, I have minutes and I have feet. So remember, time controls everything. So our domain is the time, and our range is the feet. Alrighty, so to find my domain in interval notation, the least amount of time that the roller coaster can go is 0, right? Because you can't have negative time. And the longest that the roller coaster is taking to pull this cart up is 2 minutes. When I think about the range, right, we're assuming that the roller coaster's starting at ground level, because people have to, like, get into the roller coaster. Now, if this was a roller coaster that started underground, I don't know, like, in Disney World, doesn't Space Mountain start underground? I don't actually know. It's been over 20 years since I've been to Disney World. But, or Disneyland. But I think, if it started underground, that could be a negative number. Oh, Miss Caswell. But I'm assuming it's ground level, so we're going to call it 0, okay? Because it doesn't say it starts underground. And then it goes up to 75. So when I go to write my inequalities, right, our domain has a 0 and a 2, so we put our compound inequality. Domain uses x's. And our range, again, is another compound inequality, because there's 2 numbers. And it uses y values. So there it is, friends. Domain and range. Remember these nice discrete ones, you just list the values and you use the curly brackets. On continuous functions, you're using either parentheses or square brackets. So don't forget, that's important in your notation, whether you use the curlies or the squares and normal parentheses.